Quick update this time, and I really mean quick. Two major things that I've done. One of them is very subtle, and that is I just debugged a heck of a lot and improved the level system to the point where we can load in more complicated levels and play them without with a room system with doors and rooms and things, so that the plane count doesn't get out of control as levels get larger. Second thing is, you may remember there were some limits when we were passing through the data just as pure uniforms. There were size limits on that. We've got past that. And the way we got past it is I created two textures. One texture stores the sphere data, the other stores the plane data. Now these textures are, just go wherever I created them, here in create resource images. I am going with up to 1024 spheres and planes. It can store that. It can store a lot more than that. And what I'm doing is across the x-axis are the attributes of the objects, and down the y-axis is each new object. So what do we have? We have storing a center, a radius, and a material index. Okay, well, the center takes 3 floats, the radius takes 1 float, and then the material index is another float. So we have 5 floats. We are doing red, green, blue, alpha, so we can store up to 4 floats per pixel, which means we use 2 pixels to store the data. And this can be more clearly demonstrated. Did I say this update was going to be short? I swear this is going to be short. Okay, so if we go to update, no, let's go up here. So when we record sphere data, we've got 2 pixels for every sphere, which is a stride of 8 bytes. Well, okay, a stride of 8 32-bit, you know what I mean? Anyway, 8 attributes basically. So again, the sphere is the first 3 numbers, and then we have the radius and the material, and the plane is very similar. We just have a lot more data, but it goes with a kind of similar layout. Enough talk. Let's load this up. So a bit more info about what this actually is. I've created a series of color buffers of various resolutions, so that at any point in time, every frame, every second, the engine is testing its own frame rate and seeing if it can push the resolution a bit harder. And I like to load it from the lowest possible resolution because I like that kind of pixelating in, kind of warping in effect. So what we've got is we're playing around. We've got some different parameters: roughness and reflectance. So if we look at this blue wall here, this has pretty high reflectance and a pretty high roughness. This one has just an extreme roughness. And yeah, varying degrees of that. This object here has high reflectance, low roughness, anyway. And these are all randomized. So as we can see, we can pop through a door and we go into a new room. We could pop in another door. It's not perfect, right? So when I stand on this door here, I can see this room and the other room, but I can't see the doors linking them. So it's not perfect. We can always play around with that a little bit more. And as for the noise and the roughness and stuff, it looks a little dodgy at the moment. I think that's going to improve when we put in textures. It'll look more natural. But yeah, look, this is really a stability update. I just wanted to get the system more stable, which it does seem to be. And yeah, the next step will be textures, and looking at like a hybrid rasterization / ray tracing, like playing to the strengths of both. For one thing, if we look at this green texture, we can kind of see some little super bright pixels. That's kind of like mathematical rounding errors and things. So it's not a perfect system doing pure raycasting. It has some glitches. So I want to get past that. Anyway, I've talked too much. Have fun, and I'll see you in the next update. Bye.